Let's refresh our memories on transformation of functions. Remember, transformations of functions are when we take a function and we modify it with a constant, and it could shift it vertically or horizontally or stretch or compress that. So if we have a function f of x and we add a constant on the end, now that constant could be positive or negative, so remember what it does to the function. That makes a vertical shift. So if we had our square function f of x equals x squared, and we said what would it look like if we added 1 on the end, we would add 1 to all function values, so it would shift everything up 1. If we took the function and we subtracted 3, it would take all the function values and they would all be 3 less, and so it would vertically shift the function down 3. So remember that added on the end of the function would cause a vertical shift in the function. Now what if we had the function and where the x was, instead of x we put in x minus b? Now if we looked at our cubed function, this would cause a horizontal shift. If we put x plus 1 in the function, we would have x plus 1, the quantity cubed, and that would shift the graph to the left one. Remember, on the horizontal shifts it is opposite direction, because we could express this x plus 1 as x minus a minus 1. If we had f of x minus 3, we know that that would shift it to the right 3. Now we could look at those two transformations combined. So if we look at our square root of x function, we could transform it both vertically and horizontally. If we had f of x equals square root of x plus 2 and then plus 3 on the end, we know that that x plus 2 would be a horizontal shift to the left 2, and then the plus 3 on the end would shift it up 3. What happens when we put a constant in front of a function? So we multiply the function by a constant. This would be a stretching or compressing of the function. If we multiply by a non-zero real number, then that is going to cause the function value to be multiplied by that number. If we multiply by 2, the function value is going to be twice as much. If we multiply by a half, the function value is only going to be half as much. So if we look at our absolute value function, if we multiply all of the y values or the function values by 2, we can see that the function would get steeper quicker. Instead of at 1 getting 1, at 1 we would go twice as far. We would get 2, and so forth. So if we multiplied by 4, at 1 instead of going up 1, we would go up 1, 2, 3, 4 times as high. And so we can see that that would be even narrower here. So if we have a real number greater than 1 that we're multiplying by, we would have this vertical stretch by this factor of a. Now what happens if a was positive but it was less than 1? So we've got something between 0 and 1. If we multiplied it by a half, at 1 instead of going up 1, we would only go up a half as far. We can see then what that would do to the function. And so each value is half as much as the original y value. If we had 1/4, we'd only go 1/4 as far, and we can see what that does. So if a is positive, if it's between 0 and 1, it is vertically compressed by a factor of a. So what happens if a is negative? And if we had negative f of x, that is a reflection about the x-axis, and we commonly kind of say it flips it over. So let's kind of summarize. We should do reflections before our vertical and horizontal shifts unless told otherwise. Given something like this, if we needed to reflect this with a negative, we would do that, and then we would horizontally and vertically shift. So we know if the a is greater than 1, we have a vertical stretch of a. If the a is between 0 and 1, we have a vertical compression of a. If the a is less than 0, so that means it's negative, then we have a reflection about the x-axis, as well as then whether the stretch or compressed depending on the absolute value of a. Now if we have f of negative x, so we put a negative x in the function, that's a reflection about the y-axis. We would have a vertical shift of k being a number added on the end, and we would have a horizontal shift of h. So let's just put all of that together in an example. So if we wanted to graph f of x equal negative 1 over x minus 2 plus 1 using transformations, we look at this and say, oh, this is just my reciprocal function with some transformations applied. So we know what 1 over x looks like just out of our head from our library of functions. Then we know the negative sign would reflect that about the x-axis, so now the green graph. And then the plus 1 on the end is a vertical shift, so that would move it up 1. And then the negative 2 that is there with the x would be the horizontal shift, so that would move it to the right 2. So our final graph would look like this. And based on just knowing our basic library of functions and then applying transformations to them.